We've been given the function y equals -2 cosine of -2 pi over 5x minus 2 pi over 5, all in brackets, plus 1. And we're being asked to find the x coordinates when the y value is equal to 2. Okay, so we're solving this equation. Now we've been given the graph and the value y equals 2. So we're just going to first of all look at what this solution looks like. So if I graph this, my blue line is y equals 2. The red line is my cos equation. And I can see that I have solutions. I have two primary solutions at 0.6 repeating and 2.3 repeating, but I also have repetitions. Now, my repetitions, you might notice that they are 5 apart. So from 0.6 repeating to 0.5 repeating, 0.6 repeating, there's a distance of those two equivalent solutions or coterminal solutions of 5. So we're going to make note of that because we're going to end up solving for how we can get that. So going back to my equation here, I need to solve this. So I'm going to make my y equal to 2, and then I'm going to make my equation, make that equal to my equation of -2 cosine of -2 pi over 5x minus 2 pi over 5 plus 1. And I'm going to solve this algebraically. Okay, to do this, I'm just going to, first of all, subtract 1 from both sides. I'm going to divide both sides by -2. And I end up with cosine of the angle here, -2 pi over 5x minus 2 pi over 5. Okay, so then I want to solve this. I could use my circle. So I'm looking for a cosine, the angle where the cosine value is equal to -1/2. So one place that's equal to 1/2 is right here in quadrant 2, in that position. So -1 and 2. That angular position is 2 pi over 3. So I know that theta 1, I'm going to write like this, -2 pi over 5x minus 2 pi over 5, my theta 1 value is equal to 2 pi over 3, and I can solve that equation. I also know that it shows up in quadrant 3, okay, in this position here, and I'm going to go backwards in this direction, and this is -2 pi over 3. So I also know that I have a second solution, -2 pi over 5, x minus 2 pi over 5, and that's equal to -2 pi over 3. Now I still need to solve for x here. Just one last thing before I solve for x, I'm just going to write my arc cos version of this. So the arc cos of -1/2 is equal to the angle -2 pi over 5x minus 2 pi over 5. Okay, so this is just the arc cos version of that equation in black that I solved for. All right, so I'm going to go ahead and solve for both of these solutions. So I'm going to end up with, in this case here, solving this. I'm going to first of all maybe multiply everything by 15. Okay, so I'm going to times everything by 15 here. Get rid of these denominators. I end up with -6 pi x minus 6 pi is equal to 10 pi. I'm going to divide everything by 2 pi, so I'm going to just divide by 2 pi to simplify this out. So I end up, let's divide by -2 pi to get rid of that negative in front of the x. So -2 pi, I'm going to end up with 3x plus 3, and that's equal to -5. Okay, I think that's right. So I get that, and then solving for x, I get x is equal to negative 8 over 3. Okay, and this is negative 2.6 repeating. I round that to 2.67. Okay, so now if we take a look at our graph, if I look at my solution, I've got a solution here at negative 2.67. Okay, there it is, negative 2.67. Okay, so that's one solution. And then looking at the other solution, I'm going to solve for the other side here. I'm going to multiply everything by 15 again. So times by 15, and let's divide by negative 2 pi at the same time. So I'm going to end up with 3x plus 3, and that's going to be equal to, in this case, positive, it's going to be equal to positive 5. So then solving for x, I get x is equal to 2 over 3, or 2/3. So that's my other primary solution. And if we take a look at our Desmos here, let me just get rid of some of these here. Those are my two primary solutions. And they are, although they're in different periods, those are my two primary solutions, and everything else is just a repetition. Okay, so then that's the last thing we're going to look for is our repetitions here. Our repetitions are going to be based on our period. Now, there's two ways to work out the period. So if you recognize that this is already in the period form, the denominator 5 represents the period. If not, we can just use our formula and just divide by the b value of 2 pi over 5. And in either case, our period works out to be exactly 5 units. So then to find all the repetitions here, I'm just going to go plus 5n for the green one, plus 5n, and I know that n repeats as an integer. So these, as long as we go up by increments of 5 or go down by increments of 5, we're going to get all the solutions, all the repetitions of these two primary solutions at negative 8 over 3 and positive 2/3.